Now I will discuss about different basic continuous time signals. First one is unit impulse. Del of t value is infinity when t equal to 0. Its value is infinity at t equal to 0, 0 when t not equal to 0. And value may be infinity, but the area will be 1. Integration means area. The area under impulse is 1. That's about impulse signal. Next one is step signal. Its value is 1 when time is positive, 0 when time is negative. Next one is ramp signal. Its expression is t when time is positive, 0 when time is negative. Next one is a unit parabola. It is t square by 2 when time is positive, 0 when time is negative. And another one is RECT, rectangular signal. RECT means its value is 1 when it is from minus half to half. From minus half to half, its value is 1, 0 outside this range. That's about RECT 1. Next one is signum. Signum is 1 when time is positive, 0 when time is negative. Sorry, minus 1 when time is negative. Its value is 0 at t equal to 0. Next one is a triangular signal. If the triangle is from minus t to t and height is a, then this is the expression, general expression for a triangular signal, a into 1 minus mod t by t, where mod t less than t. Outside this range, its value is 0. Next one is a sampling signal. SA of t. SA of t is sin t by t, and this is the diagram. Sin t by t is called sampling signal. Its height is 1, maximum value is 1, and it will be 0 at pi, 2 pi, pi, minus 2 pi, and so on. Next one is a sync signal. Sync is sin pi t by pi t. The previous signal is sampling signal. Sampling signal is sin t by t. This is sin pi t by pi t. Maximum is 1, and the signal will be 0 at 1, 2, 3, and so on. Similarly, minus 1, minus 2, minus 3, and so on. At these points, it will be 0. That's about sync signal. Next one is exponential, real exponential signal. E power at. When a is positive, it is like this, growing exponential. E power at diagram is like this, it's a growing exponential. If you take e power at, growing exponential, you take right side, that is a positive time, it is multiplied with u of t. Negative time, it is multiplied with u of minus t. It's a growing exponential. If you observe with respect to time, the value is growing. E power at is growing. Take 0 to infinity, that is u of t term. 0 to minus infinity, u of minus t term. Next one is a decaying exponential, e power minus at. It's decaying with respect to time. If we take this side, multiply with u of t. If we take this side, multiply with u of minus t. Next one is a double exponential. Here e power a mod t will be like this. This is the expansion of e power minus, expansion of e power a mod t, e power 8 into u of t plus e power minus 8 into u of minus t. And this is another double exponential, minus a mod t. Here a mod t, minus a mod t. If a mod t, it is like this, minus a mod t in this manner. Next one is complex exponential. E power st is called complex exponential. where S is a complex frequency which is sigma plus j omega. If you substitute sigma plus j omega in place of S, it is like this. Here first case is sigma equal to 0. If it is sigma equal to 0, it is e power 0 1, it is just e power j omega t. It is like this. E power j theta means cos theta plus j sin theta. So if you draw a real part, it is like this. Real part is cos omega t and imaginary part is sin omega t. It's like this. That is when sigma is 0. When sigma is 0, this is the diagram of e power st. When sigma is less than 0, the sigma is less than 0. If sigma is negative, it is a decaying exponential. So now this decaying exponential is multiplied with cos and decaying exponential is multiplied with sine. This is the real part of the signal. This is imaginary part. Here e power j theta means cos theta plus j sin theta. That's why it is like this. So here decaying exponential is multiplied with cos. So this is the diagram. It's like a cosine waveform, but the amplitudes will reduce. It's like sine, amplitudes will reduce. This is the imaginary part. This is the real part. Next one is sigma greater than 0. Once again e power st, sigma is greater than 0. So here sigma is positive, it's a growing exponential. So this is the real part of it, this is the imaginary part of it. So it will be like this. It's growing with respect to time. It's like cosine and sine, but growing with respect to time. Next one is sinusoidal signals. This is the diagram of cos and this is the diagram of sine. That's about continuous time signals. Next we'll discuss about discrete time signals. So this is a unit impulse. Its value is 1 when n is 0. Its value is 0 when n not equal to 0. Only one sample will be there at n equal to 0. The next one is a step signal. Its value is 1 when n is a positive, 0 when n is negative. Next one is ramp signal. Its value is n when n is a positive. So it is like this. Next one is a rectangular signal. Its value is 1 from minus n to n. Next one is a exponential signal. A power n is called exponential. For different a values, the diagrams are like this. When a is between 0 and 1, it is like this. If it is minus 1 to 0, it is like this. A is more than 1, like this. A is less than minus 1, it's like this. Next one is a double exponential. Double exponential means a power mod n. So these are the diagrams of double exponential for different a values. Here a is 0 to 1, it is like this. A is more than 1, it is like this. And discrete time sinusoidal signal.